we go until 9:30. Occasionally, I'll hold you just a little bit past 9:30, and I try not to, but sometimes it happens. Okay. And if for whatever reason you need to leave early, or you can't make it to class or something, that's fine. My feelings won't be hurt, but just make sure, I record these videos for you, so if you miss stuff in class, you can catch up and will not be super far behind, okay? Try not to miss class, but if you do miss class, make sure you watch the video, okay? Because if you miss a day, it's actually a full week of content, and especially later on in the course, a full week is a lot of material. So, the class starts off easy, and then it just it's going to feel like it starts going really fast. Okay, and it's not that we're doing a whole lot more towards the end. It's just the stuff at the beginning is easier stuff. So we're still covering a lot of material in the beginning, but it's like easier to handle, and then later on it's just tougher stuff. All right, so let's just start off with what is statistics all about? Okay, so we got statistics. This is introductory statistics. So what is statistics all about? Okay, all right. And so I heard someone in your name,
Kurt.
Kurt. Okay, so Kurt said it's the study of data. Okay, and that's a great definition of statistics. And so let me just expand on that a little bit, because we're gonna have to talk a little bit about what exactly is data and all of that. But what is statistics all about? Okay, it's all about studying data and being able to make conclusions and decisions from the data. Okay, so it's not just looking at data, but it's also being able to draw meaning from the data. So let me just write that down. Okay, so analyzing. Statistics is about analyzing and describing data so that we can draw meaningful conclusions. Meaningful. I can spell. Alright, so I hope you guys can all see and read my handwriting, and especially, those of you who are in like that back half, there's like that, where the steps start going up. I encourage you to sit closer to the front, okay? Especially that back row, it's hard to see everything, and it's a little bit hard to stay engaged in the class. In the front, it's easier to stay focused and pay attention. Okay, so what's statistics all about? Okay, so what does what does this even mean? Okay, why are we trying to draw meaningful conclusions from the data? And what is this? What does it incorporate? One of the key things that we must understand about data, okay, is there is variation. Okay, and so data is basically information that we've gathered in some kind of context, and when we gather that information, we also have to understand that there's variation. So let me just give a brief definition of data. Okay, so data is information that has been Data is information that has been gathered, and we hope, okay, hopefully, or we hope that it's organized and in context, okay? And we hope it's organized. Context. Okay, so just having numbers all by themselves are not data, okay? I could write okay, and these numbers, they're not meaningful, okay? They're just numbers, okay? But if I tell you that these are ages of people, then it suddenly adds meaning, okay? And we're still missing something in that, you know, what is the context? Okay, so I told you, so first off we have numbers and it's meaningless all by itself, okay? But it could be ages of people, and suddenly that adds meaning to these numbers, okay? But then, yeah, we also are lacking a context, and so I could say these are ages of the children in a family, in one family. They could be ages of, I don't know, 5 patients in the hospital, okay? There's all sorts of things, and essentially, whenever we collect data, there's a lot of times a story behind the data that we've gathered. Okay, and sometimes the stories are much more interesting than other times, but there's a lot of context. So the context could be maybe ages of children in a family, or maybe ages patients in a hospital wing, whatever. Okay. There's and we can have all sorts of different contexts, but it drastically changes the story behind these numbers. Okay. And sometimes you'll see numbers just or data collected as a list of numbers, just like this. A lot of times we will see data in the form of tables. Okay, so sometimes we have data in tables. And so here we've only collected one bit of information, or one piece of information from people, right? So we said, you know what, we're not interested in anything else about these people, but we just want to know their ages. Okay. Other things, we could say, you know what, maybe we're interested in more than just their ages. Maybe we say we want to know the age of the person, and we want to know the sex of the person, and maybe if it's patients in a hospital wing, we want to know maybe what is their condition, and maybe we want to measure their weight. Okay, and we can collect all sorts of different pieces of information here. Okay, and if this is how it goes, you can imagine setting up like a spreadsheet of information. In each row, we would have a different person, right? We would have person 1. And person 1 would have a name, but you know, person 1 may be 10 years old. Maybe this person is male. The condition may be stable, and weight. I don't know, what is a 10-year-old weight? Okay, 80 pounds or something. I don't know. Huh? No? Less? Not today? All right, yeah, you know. Who knows? Okay. All right, person 2. Well, maybe that, you know, in the hospital for whatever reason. Okay, person 2, you know, 18, female, and maybe, what other conditions do they have? Oh, critical, now I feel bad.
Why does it have to be critical?
Huh? Why does it have to be critical? I don't know, okay? And maybe she weighs,
120.
okay, I was gonna say 115, but okay. And so now, like, this is just made up people, but now suddenly there's like an emotional attachment to these things, okay? And that's, one thing we must not forget is that a lot of the time, statistics or anything, whenever we collect data, it's about people or the things that we've collected data on, okay? And sometimes when you just reduce things to numbers, we forget that these are people, and someone will be brokenhearted if this person doesn't. I'm not trying to laugh, but there's stories here, okay? And even if you can't see the tears, it is about people, and we must not forget that. And anytime we're making decisions and things like that, we have to remember. And so a lot of maybe you will not be in a position where you're going to be doing statistics every day and making decisions, okay? But all of you will, be affected by decisions that other people make, and a lot of times the decisions that other people make or things like that are influenced by statistics. And it's good to have, and some of you will make decisions based on statistics that are presented to you. So it's important to have a decent understanding of the statistics that you are being shown, and to not be, quote, taken advantage of, or by being lied to by poorly done statistics. And sometimes statistics are not done poorly on purpose, but just because people didn't have a full understanding of what's happening. And so anyway, so this would be an example of a data table, and you can see that each row represents a case or a subject. Okay, and so when we gather data, okay, so in our each row is a case or subject, and the columns are different pieces of information that we've gathered, okay, or different pieces of information that we've collected, and those columns are known as variables, okay. And so here, I say data carries a story, and when you were in elementary school and you were learning how to write sentences and write paragraphs, they said there were pieces of information that you should include. And what were they? They were your 5 question words and the 5 W's in the H, right? The who, the what, the when, where, why, and how. And the same applies to the data. And here we see we have 2 of the W's. We have the who and we have the what. Okay, so the who are the different subjects that we've gathered information from, and the variables that we've collected, that serves as our what. Okay. As for the other W's, the when, the where, the why, and the how, and I guess that's an H, that would be the context in which this data exists. Okay, so the when, where, why, how, that would be the So, you know, when was this data gathered? Was it gathered this year? Was it gathered 20 years ago? Who knows, okay? That would describe when. You know, where was it gathered? Okay, was it a hospital in the United States, a hospital in Europe, a hospital in Africa? We don't know, okay? Or, well, because it's made up, it doesn't matter. But, you know, whenever someone presents you with a set of data, and especially if it's a set of data that they want you to draw meaning from, okay, these are questions that you need to ask. Okay? Why do we gather this data? Okay, maybe it's just standard procedure to gather this information at a hospital. Okay, or maybe someone is very nosy and going through medical records that he or she should not be going through. Okay, and how is this? Okay, how do we know someone is male? How do we know someone is female? That's a whole nother topic of debate. But you know, this puts it into a context. And so sometimes when we look at data, sometimes the data we collect is not so is not what we typically think of data. Okay, maybe we collected information. We're at an airport and we collect information on different flights. Okay, and so. So maybe I'm creating a data table. And I've got flight 1, 2, 3 and flight 94 or whatever. Okay, I don't know. Flight 77. Okay, I'm just making up numbers. All right, and maybe the bits of information, we're doing airline, and so this is American Airlines and United Airlines, and what's else? Delta.
Southwest.
Okay, alright, yeah. So, well, we get the idea. Okay, we got airline, maybe we have the number of passengers. And then so, flight 1, 2, 3, they have 100 passengers aboard, and this one has 85 passengers, and this has 212 passengers aboard or something. And they have departing airport. So this one's leaving LAX, and this one's leaving JFK. Great. Okay, and wherever. Okay, and time of departure. Okay. Okay, so in this context, what is my who?
The flight.
Airline. Flight.
Each flight is the who, okay? The who is each flight. It's not the airline, it's not the passengers, it's not the pilot of the airplane, okay? It's the flight number. Each row is a subject. That is my who, okay? So each flight has its own row, and we are collecting information about each flight, okay? So that is my who, okay? So, alright, so I'm not interested in what's happening with the airlines. I'm interested in each flight, okay? And the what, those are the column headings that I've gathered here. An important distinction we need to make is when we are looking at the what's, the different variables that we are collecting, we've got two types of variables that we can look up. Okay, so we have variable types. Okay, we have categorical data, and we have numeric or quantitative data. we need to be able to know whether something is categorical data or quantitative data. And it seems like, and I'm going to tell you what the difference is between them. And it's going to seem like it's so easy and that you don't need to worry about this. But I tell you, when the final exam comes around, there will still be students who are confused as to what the difference is between categorical and quantitative data. Okay? Categorical data means the data that we gather can be put into categories, okay? And numeric data, or quantitative data, means the data we gather measures some kind of quantity or some kind of number, okay? And it seems very simple, and we'll go through some examples, and they'll seem very clear and easy, but people get confused. Okay, so categorical data, okay? The data is in categories. Quantitative data, we've got data in quantity, in quantities, or numbers, so numeric data. Okay, so LAX, JFK, I don't know. Miami, all right. And time of departure, 6 a.m. This is 23:15, 11:15, and whatever, 13:30. All right. Okay, so in this case, our airline is a categorical data. Okay, is categorical data. Okay, because flights. Yeah, I don't know how many airlines there are. There's probably like 80 of them or 100 of them. How many airlines are there in the world? A lot, okay? But, okay, so flying out of some airport, maybe they would get different airlines, and but there's still categories, and it doesn't make sense to try to take like an average airline or some average of the airline, okay? So when you've got quantities or numbers, you can take averages, you can add or subtract them, you can do these things that you can do to numbers. When you have categories, you don't try to do that kind of stuff, okay? So, you know, looking at passengers would be numeric, would be quantitative, okay? We can say this flight had 15 more passengers than this flight. This flight had, you know, 100 whatever more passengers than the other flight. And we can do that. We can do that kind of comparison. We can't look at Delta and United Airlines and say this airline has more D's and L. I don't even know what you would say. Okay, you can't, or you know, we could take these two numbers and say the average number of passengers was 90 something. We can't say the average airline here was United America or something. I don't know. Okay, you can't take averages of categorical variables, but you can take averages of quantitative variables. Okay.
Put plane type on there, you might be able to.
You know, I would probably say no, right? You take a 747 and a 727, you can't average those and say you get a 737 or something. Numerically, that would work out, but these
the
are
number of passengers on this plane.
So if it depends. Okay, so what we're talking about could be you could have a variable which is like maximum capacity. That would be a quantitative variable. Okay, but that's not airplane type per se. Okay. Well, and some things, you know, a little bit shaky. But let's. So we got data in categories. So and data in quantities or numbers. Okay. So one of the guiding rules is you can do mathematical operations to quantitative data. Okay. Perform math operations. I guess to the values. And over here, it does not make sense to do that. Okay, I'm sorry that this is. I try to do my chalkboard work organized, but this just came out to be a little bit of a mess. Okay, so let's just try a few examples, okay, and you tell me if this is going to be categorical or quantitative. Okay, let's say we measure, we look at different people and we measure the height of the person. Is this categorical or quantitative? Quantitative, right? We can take two people and we can say this person is 3 inches taller than someone else. Okay? What if we look at their blood pressure? Quantitative, right? This person's blood pressure is what, 120/80, and this one's 115/60 or something. Okay, we can look at these numbers and we can compare them. Okay. All right. What if we are looking at cars and we say we're looking at whether it's sedan or coupe or whatever the model.
Categorical.
That'd be categorical, right? Okay. The number of seats it has.
Numeric or quantitative.
Quantitative.
Yeah.
Quantitative. Okay, yeah. Number of seats. Okay. The number of doors it has. Quantitative. Okay. Although some people might argue that the number of doors is categorical, right? You've got, when you go to a rental car place, they might say you want a 4-door car or a 2-door car, and these are just like two options that you have, and you can't have a 3-door car if you wanted one or something like that. A hatchback, yeah. Is that a 3-door? Is that, you know? Okay. Gender of a person. Categorical. Okay. But maybe testosterone level of a person.
Quantitative.
Quantitative. Okay. So it seems like this is an easy topic, and it is. It should be. But people get confused because even when we're talking about categorical data, you still see numbers. Okay. And let me just let me summarize here. Okay. So let's say we all said that that gender is what, categorical or quantitative? Categorical. Okay, so we've got gender here, and it's categorical. But then, if we looked at this classroom and we said male and female, okay. And we said, hey, there's 60 students in here, and 25 are male and 35 are female. Okay, people see these numbers and they're like, oh, numbers, numeric. Okay, it's not. Okay, this is still a categorical variable. It's just this is a summary table. And I said, and all we see is that we've got 25 males and 35 females. Okay? Just because we've got numbers here does not suddenly make gender a numeric variable. Okay? And maybe it's very easy with things like gender, but then you know, you change these up to I don't know, suffered a heart attack within the first 3 months of the surgery and did not suffer a heart attack after 3 months, and because of the, I guess, longer description, people get confused and they think now it's quantitative or something, but it's still a categorical, right? We're putting people into two categories. These people had heart attacks after their operational procedure, and these people did not. Okay, it's still a category. Okay. So anyway, this is just to show that categorical variables will still have numbers, and still, and to make things, I guess, even more confusing or harder for people, they get confused, and we'll ask things like, you know, what percent are male? So what percentage of the class is male?
25 out of 60.
Yeah, you do 25 divided by 60, and you get, you know, 41.67%. Okay, something like that. I think. So that happens, okay? And but 41.67%, it's still categorical there, okay? And actually, anytime you see percentages, it's usually going to be categorical. But then other times we'll see things like means and averages, and those will be numeric variables. Okay. Let's keep talking here. Just check the time. Alright, so going on about categorical variables, this is just to make things more confusing, or actually it's because we want to be able to talk to computers sometimes. Sometimes the categorical variables will be coded into numbers, okay? So we've got gender, male and female, things like that. If we were to create a data table, okay, when we do this, you could actually think what we have going on is we've got person 1, person 2, person 3, so on and so forth, up to person 60 in the classroom, and maybe person 1 is female, and person 2 is female, and person 3 is male, and we go on, and we've got more males and more females, and so on and so forth, okay? And all we've done is to go from here to here. We counted up how many males we have and how many females we have, and we found that we had 25 males and 35 females for a total of 60 people. So we've just summarized this column of information. Is that all right? Some people get confused with like the dots. So this is just to show that I'm not listing out all 60 people in this classroom, just the first 3 and the last couple. If we were to put this into Excel, okay, we could put this into a spreadsheet, and we would have F's and M's for females and males, and that's fine, okay? But if you've ever used a spreadsheet, you know, one of the functions you want to use is like sum, or like add up the numbers in this column, or count something, and actually Excel is smart enough today where you could say, you know, count how many F's I have and count how many M's I have, and it could summarize this thing for you, or create a pivot table, and it'll do this stuff for you. Okay, but before, it wasn't so easy. It would see F's and M's, and you would say, tell me how many F's I have, and it would not know what to do, okay? And so to get around that, what people did when they were doing data entry is they would say, okay, you know what? Instead of putting F and instead of putting M, we're going to put in 1s and 0s, okay? And so let me just see what they did. So maybe we could say F we will code as a 1, and M we will code as 0, okay? And this choice is arbitrary. If you wanted to set M equal to 1 and F equal to 0, that's fine. But usually when you have just 2 categories, you would code one as 0 and the other as 1. And so instead of writing gender at the column, this is going to be the exact same data here. We've got person 1, person 2, person 3. Instead of writing gender, we write female. And if the person was a female, we put 1, 1. And if the person was not female, we put 0. Okay, so this is kind of the notation where 1 represents yes and 0 represents no. Okay, and so towards the end we have that person who is male is a 0, person who was female was a 1, and then the other person 60 who was female, person 58, so on and so forth like this. And then if we asked how many females were there, we don't have to do we didn't need to wait for an advanced version of Excel. We could just say, oh, you know what, just take this column and add it up, okay? And however many numbers that adds up to, because each number is a 1, that's going to be how many females you have. So you add this column up, and you get, females, I get 35. And then so just by doing some subtraction, you say, well, I've got 60 rows, and if 35 of them are female, then that means the other 25 must be male. Total rows, 60. Okay. And all right, so is that okay? Good. And so sometimes we will see coding written this way. And other times, maybe we want to collect more information on our data. Okay, and so other ways we will see data, and we got this notion of stacked data and unstacked data. So let's say we wanted to not just know whether person 1 through 60 were male and female. So we go through this class and we get, just tell me if you're male or female. But for whatever reason, we wanted to get really personal information, and we asked for your weights or something like that. Okay? And so if I said, if I gave you this assignment, and we're not going to do this, but if I told you, gather information and say, I want you to create a list of, or just, I want to know the weights of everyone in class and whether they are male or female, okay? We might have people organizing their data in different ways, and they would both be valid methods for organizing the data, although one method we would prefer more for like using in a computer. Okay, so let me just show you the preferred method, and that would be each row we would go person 1, person 2, person 3, 4, so on and so forth up to 58, 59, and 60, and we would gather each bit of information would be a different column. And so this one would be gender, and this would be weights. Okay, and so person 1 was female, and she says she weighs 120, and person 2 female, and this one weighs 155, and person 3 male, and he weighs 175 or whatever. Okay, it doesn't matter. And we would gather this, and we would have a whole bunch of data like this. Okay, this would be one way, and this would be known as stacked. Stacked data. Okay. And then another way that the data could be gathered is we could create one column for the males and one column for the females, and we would have data in here. We would just say, the first female was 120, and then the next female was 155, and then we saw a male, and he weighed 175. So on and so forth. So at the end of the day, you would have a total of 25 numbers here. Maybe the last one was 190, and this is the 25th person in the males. And over on the females, you would have something over here, and you have someone 25, and she is the 35th female member. Okay. Is that okay? Yes. Question.
Is this stacked data as well, or?
No, this would be the unstacked form. Okay.
Okay.
Unstacked. Yes.
Can you go over the second one one more time? Sorry, I missed it.
Okay, so what we're doing over here is we are creating, so with the stacked data, we would have 60 rows, and in each row we would have, we would collect the gender and the weight over here, okay? Over here, this would, quote, I guess, be a little bit easier, faster to write down, because you wouldn't have to write person 1 through person 60, but you would just say, oh, you know, you'd go around and you'd say, you'd say, oh, you are a female, and then you ask, what is your weight, and she tells you, and you would just write her weight down under the female column, okay? And as you go through the room, you would probably catch 35 numbers under the female column, and over here you would get 25 numbers under the male column, okay? And actually, looking around, you probably get, it's probably not even 25, 35, there's probably even more women in the classroom. But, well, I don't know. So this, you would just write down the numbers, and you wouldn't even bother writing, this is person 27, and this person 27 was male and weighed 145 pounds or something like that. Okay, and so one of the advantages of having stacked data is that we could add more columns, okay? We could add, so here we're collecting 2 bits of information, but we could collect a 3rd bit of information, the height of the person. We could add more columns, and it does not complicate our data set that much more, okay? Over here, how would we add, you know, a 3rd column? It would just get really messy, right? We would say, oh, okay, well, these are males, and now I'm going to match up another number along with this thing. It gets really messy, and this unstacked form is really only ideal if you're only collecting 2 bits of information, one being maybe one categorical variable and the other some kind of numeric. So that's looking at quantitative data. So we looked at summary tables for just one variable and things like that. So let's look at categorical data again. And let's say we want to collect different bits of information. And let's say both of the bits of information we wanted to collect were both categorical. Okay? And so maybe we have person 1, and maybe what's the first bit of categorical information? Sure, their sex. Okay, whether they are male or female, their gender, and if we go around the classroom and we ask, what's another categorical bit of categorical information we could gather? Huh? Eye color. So not age. Age would be
Oh yeah, sorry.
would be numeric. Okay, yeah, we could yeah, there's all sorts of information. We could ask what's your eye color, okay? Although, how many categories would you define, right? Is there difference
Right-handed, left-handed?
Yeah, right-handed or left-handed. That's an easy one, okay? So yeah, let's just go with that one, okay? Handedness. Okay, and we say, okay, so the first person we talk to maybe is female and she is right-handed. And then the second person we talk to maybe is male and he is right-handed. And then the third person is female and she is left-handed, or whatever, okay? And we go through, we get 60 people, alright? And so now we want to make a summary table. How would we make a summary table with all of this information? Okay, so let's actually, just because some students get confused, I'm going to actually just list off, maybe not 60, but maybe like 8 people, and we will make the summary table based on these 8, okay? So, forgive me, I'm going to just write 4, 5, 6, 7, and 8, and I hope we can all see this. Alright, so what do we have? Okay, we'll have female, female, male, male, female, and we'll go right, right, left, left, right. Okay, I just made up things there. Okay, it doesn't matter. 8 people. All right, so I've got 8 people, and so I'm going to make a summary table. All right, so let's say we want to just make a summary table for one variable at a time. Okay. So if I make a summary table for sex, what would this look like? What would my first row here be? Okay, so we can write male, and then we can write female. All right, and so what number would I put here, or what would I put? 3. I've got 3 males. And how many females? So 5, and my total is 8. Okay. Alright, and then if I create one for handedness, so this is what looking at one variable at a time. What do I have going on?
Left and right.
I have left and right. Okay, and how many left-handed people do I have? 3 and 5. Okay, that's just coincidentally what happened over there. Okay, but sure, that's fine. That's handedness. Okay, so that's creating summary tables for just one variable at a time. Right? And I just want to make sure that there's no questions on this, okay? Yes?
Just the board above, when you said the stacked data, so is it always true that the subject or the who is stacked, and the like the male, female, that's subject or who is, I mean, I'm just trying to get that, because when you do this down there, it would make more sense. Like, why is it called stacked?
Okay, so I have a question. Is this data in stacked or unstacked form?
Columns of categorical data.
Yeah, it's in stacked form, okay? And it's because we are each row is a person. Okay, so up here, each row represents a person, and in each row we can collect multiple bits of information. Okay, I'm sorry, your name is
Melissa.
Melissa. Okay, so Melissa, can you just tell me what was person 3's weight?
175.
175, and person 3's gender?
Male.
Male. Okay, and so each row, it's you can see that each row is we have multiple bits of information on that person. Okay, and so the reason why it's stacked is because all of the people are in one column. Okay, over here we don't have all of the people in one column. Okay, it's not, we don't have a list of all 60 numbers here. Over here I've got one column of 25 people, and I've got one column of 35 people. and it contains the same information. We've got their gender and their weight. We still have that information, but we've got a column for the females and a column for the males.
So stacked is when they're intermixed.
Kind of, yeah, intermingled, and all of the people are just form one list. Okay, here we're creating 2 lists, or however many lists we need to cover the different categories we have. Okay, over here it's stacked because we've got all 8 people in one list, and we've collected whether the information on their sex and their handedness in the attached columns here. Is that? Are you still a little bit lost or confused there?
Okay.
You're okay? Okay. So I mean, if you've got questions, don't hesitate to ask. All right, and I'll do my best to answer it. And if I feel like it'd be better to just kind of move on, I'll let you know, and then I can answer the question in more detail afterwards or something like that. Okay, so I'm going to create a summary table and try to incorporate both summary tables in one summary table that has all of this information here. Okay, so this is a summary table where we're going to look at both variables, both categorical variables at the same time. Okay, and this is sometimes known as a two-way table. But I'm going to create, I'm going to look at sex, male and female over here, and then I'm going to look at handedness, and I'm going to have left, right. Okay, so we'll have a total. Okay, so some bits of information will move directly over. Okay.
This is another type of summary table.
Yeah, this is another type of summary table, and this is where we're looking at both variables. It's sometimes known as a two-way summary table. Also sometimes known as a contingency table. There's all sorts of names for these things. People thought they were real creative and came up with something new, but then they made up additional names for these things, but it turned out to be the same thing. Two-way tables, contingency tables, all this stuff. Okay, well, some of the information moves right over. Okay, so here, total number of males that I saw in my list of data, what is that? 3. Okay, so a total of 3 males over there. And then total number of females, 5 for a total number of people, 8. Okay. Total number of left-handed people, 3. And what's your name? Niall. Okay. So Niall, I understand. So you got this really good. But let's see. So Melissa, could I pick on you and say what number goes over here?
Okay, where, from those 2 tables?
Yeah. Just so. Seeing what we've seen here on the categorical data, okay? On this, we've collected information on 8 people, and we've looked at their sex and their handedness, okay? And we've created summary tables here already on their sex and handedness. So I'm asking, what number goes right here, which would represent the total number of right-handed people? So I was asking Melissa here.
Well, that's 5.
Okay. Yeah, so the answer there is 5. Okay. All right. Okay, so Melissa, if I'm going to pick on you and again, and this is going to be a tough question, and if you don't get it right away, that's okay. Don't. There's no shame in it. And I'm sorry, is it okay that I'm picking on you?
Not really, but
No,
go ahead.
not really? Okay, I'll pick on a different state. I don't want to make.
Sure, go ahead.
I don't want to
It's
make
fine.
anybody feel
I'm
uncomfortable.
so worried. I'm still thinking stack just means this, so.
Okay.
I'm kinda-
Okay. Well, so we're doing this thing with categorical data. Okay. So in this cell, okay? The answers will not be in our summary table, okay? We gotta go to this table of actual data here, okay? In this box here, this is gonna be the total number of males who are what, left-handed or right-handed? What do you think? Left-handed, okay, so the total number of males who are left-handed. And so Melissa, tell me, if you look at this data here, what number would you say goes into that box? 2, because you see 2 males who are left-handed. Good, okay, so I'm gonna put 2 here, which means what number goes over here?
That might be 6.
6.
Well, wait a minute, I'm sorry, there are 2 left-handed males. So how many right-handed males?
Mm-hmm.
1.
1, okay? And so let me just show you the relationship of the cells within the table. Here we know that there's a total of 3 males, and we see that 2 of them are left-handed, which means 1 has to be right-handed, okay? So then if we see that there's a total of 5 right-handed people, and 1 of them is male, how many are female? 4, okay, good. And so I think we got this, and so this would be a summary table that shows us the breakdown of all 8 people into male, female, and left-handed and right-handed. Okay, so that wasn't so bad, and you actually see a lot of these kinds of data in, I don't know, newspaper reports and things like that. They might have more categories than left and right. Maybe they'll have at this time of year they'll have things like Democrat, Republican, and Independent, or not affiliated with either of the other 2 parties, or something like that. And maybe they'll still break it down male, female, or maybe they'll break it down to, Los Angeles and Orange County or something. I don't know, whatever. Okay. Yes, we have a question.
Do you only do this with 2 variables or more?
Yes, so you can only, so this kind of table, a two-way table, you can only do with 2 variables, okay? 2 variables does not mean 2 categories, okay? Because I could have a variable that has 3 categories, okay? But this is still only 2 variables. So if I asked, if we were to go around and say, like, tell me, are you male or female, and tell me your political party, okay, we could have Democratic, Republican, or I guess neither, or independent, whatever you want to say, and male or female, and we could go around. How many variables do I have here?
5.
2.
I have 2 variables. What are my 2 variables?
Male and female.
Gender and
My 2 variables. My 2 variables are gender and political party. Okay. Okay. Gender is categorical, and there's 2 categories. Okay, and political party, at least the way we've defined them here, there's 3 categories, okay? On the ballot for president, I don't know, there might be like 8 parties represented or recognized by whatever, Los Angeles County or something. I guess, you think every ballot would look the same across the state, but they don't, right? Some counties recognize some parties and others don't, so that's interesting. But, okay, so yeah, so don't get what a variable is mixed up with what a category is, all right? 3 categories, 2 variables, okay? And we might see, okay, so I'm just going to make up numbers here. Okay, maybe we see 15. Oh no, that's too many. No, I just I said, well, so far there's only 20. I'm making up numbers, right? But there's 25 males and 35 females. We can't have 15 and 20 because that would mean there's 35 males. So. So maybe this would be 15 and 6 and 14 or something, and 10 and 10 and 5. Okay, just totally making up numbers, and we would see 35, 16, 19, and 16. Okay, so this is. Total.
That 25?
25.
Did I add something up?
Yeah.
Wrong? Yeah, I did. I can divide numbers, but I can't add them. Okay. Okay, well, good. So this is just made up numbers, and I could ask questions like, from this class, what percentage of students are Democratic males? Okay, so you don't have to give me a percentage, but what numbers would I take and compute, and what would I do to get this answer?
10 over
10 or 25.
You use the total number.
So I
and
would say,
take
what
that
percentage of students are
10 divided by
Democratic?
10
25.
divided by 25.
No, 10 over 60.
So I'm hearing different things. I hear some people saying 10 over 25,
Yeah.
and
Oh,
some
no,
people
you
saying
add
10 over
25 by
60.
guess
Some
it's-
people
oh,
saying
then
I
60.
should add this and that. What do I do?
Oh, yeah,
10
10
divided by
10 over
60.
60.
10 divided by 60. Okay. What percentage of students, okay, of students, how many students total do I have? 60. So 60 is going to go on my bottom here, okay? So I get 10 divided by 60, 16.7%. All right. Okay. I could ask a different question, and they're all going to sound similar, but they're very distinct from each other. And this is one of the things. And so those of you who are native English speakers, maybe you'll pick up on the differences very easily. And those of you who are not native English speakers, this might present a bit of a challenge. So just make sure you understand what we are asking here. Okay, so I could ask, what percentage, and even those of you who are native English speakers, it could present a challenge because it's still just, it looks weird, right? Okay, so what percentage of males are Democrats? And what do I do here?
10 divided by 25.
Now I do 10 divided by 25, okay?
40%.
So that would be 40%. Okay, very different answers, 16.7 versus 40%. All right, and then what's the other form of the question I could ask?
Percentage of males are independent.
What
No, it would
percentage
be
of
what percentage
Democratic-
of Democrats. Oh, and this is just coincidentally unfortunate. Okay, what percentage of Democrats are male? And I was hoping to have
10
a
over
different
25.
question. It's also going to be 10 over 25. 40%. Okay, so I was hoping the numbers would be different, but the way I made them up, they ended up being the same. Sometimes that happens. Okay, well, the key here is when I said percentage of males, which 25 am I dividing by? Am I dividing by this 25 or this 25?
That one.
B.
Okay, so who thinks, we'll call this one A, and we'll call this one B. Okay, so who thinks it's A? All right. And who thinks it's B? Okay, so the answer for this one, what percentage of males are Democrats? So I'm going to just label this A and this B, okay? This one is going to be 10 divided by, 10 divided by the B, okay? And what percentage of Democrats are male? I'm going to do 10 divided by the A there, okay? And the reason for that is because here it says percentage of males, I'm gonna look at the total number for the males, which the males are represented in this row, so I'm looking at the total number of males here. Okay, and over here it says percentage of Democrats, so we're looking at this total column for Democrats, that number is 25, so I'm using this one. Okay. Alright, for some of you this is like very boring and basic. Others of you, maybe it's tricky or challenging, okay? Just bear with one another for now, okay? Let's see, how are we doing on time?
8:30.
Oh, let's take a break, let's take a break.